Welcome to the walkthrough for Assignment 4, Part A. The objective of the first part of this assignment is to learn how to use the Java Fork Join Framework's Common Fork Join Pool and its ManagedBlocker interface, as well as the Java CyclicBarrier and CountDownLatch barrier synchronizers. I recommend you watch the following videos to ensure you understand all these Java classes. A video describing the Common Fork Join Pool appears here. Videos describing the ManagedBlocker interface appear here and here. And videos describing CountDownLatch and CyclicBarrier appear here and here, respectively. Naturally, these topics are also covered in class. In this part of the assignment, you use the Java Common Fork Join Pool and its ManagedBlocker interface to create a dynamically resizable pool of threads that allow beings from Middle-earth to concurrently gaze into a given number of Palantiri. Likewise, you'll use a CyclicBarrier and a CountDownLatch to coordinate these beings so they start and stop fairly and efficiently, respectively. This Palantiri simulator app is packaged as a project using the latest version of Android Studio. The app is written in both Kotlin and Java and demonstrates many Android capabilities. For the purposes of Assignment 4A, however, you only need to be aware of the following three directories. Simulator Manager's Beings Fork Join Pool, which contains the skeletons you'll need to fill in, as we discussed below. App Source Test, which is a set of unit tests that exercise many Palantiri simulator features and can be used to help test the functionality you implement for the assignment. And finally, App Source Android Test, which is an Android Studio instrumentation test that runs your app automatically. You'll also need to integrate your enhanced solution for the concurrent map fair semaphore manager.java folder from Assignment 3B and use it as the implementation of the Palantiri manager for Assignment 4A. Please address all my comments from Assignment 3B in your Assignment 4A solution. To compile this code, you'll need to use the provided Android Studio project. You can run this project by clicking the green Run App button in the Android Studio IDE, which should automatically select an Android emulator to run, assuming you have one created. The app's minimum API is 29, so you need to have selected an emulator that uses an API greater than or equal to 29, though I recommend you use API 30. If you don't already have an emulator created, you can create it by clicking on the AVD Manager button in the Android Studio IDE. You'll need to modify several files containing the skeletal Java code by completing the to-do you fill in here tasks to provide a working solution. Don't change the overall structure of the skeleton. Just fill in the to-do tasks and don't delete the to-do tags. In particular, you need to finish implementing the following to-do tasks for this assignment in the Fork Join Pool folder. First, there's the Fork Join Pool Manager.java file. Here, you'll need to complete the to-do tasks in various methods to implement a being manager via a dynamically resizable thread pool using the Java Common Fork Join Pool and its ManagedBlocker interface. Next, you'll have to update beingBlocker.java. Here, you'll need to complete several methods in this class, one of which should be very familiar by now, but several of which are brand new. And finally, as always, the student.kt file, where you'll need to complete the to-do task to set the type field to either graduate or undergraduate, depending on which version of the assignment that you're implementing. Your app will be considered correct if it passes all the unit and instrumentation tests and all beings successfully complete all their n iterations. A correct simulation should restrict the number of gazing beings to the number of Palantiri. In other words, if there are 4 Palantiri configured in the simulation, then only 4 beings should ever be gazing on the screen at any given point in time. When the simulation is running, the app view will display visual feedback to show Palantiri and being states, as well as the progress of their gazing iterations. If your assignment implementation is correct and doesn't throw any exceptions, then the app title bar labels will appear green when the simulation completes. If the implementation is not correct, however, or if it throws an exception, then red title bars will be displayed when the simulation completes. Graduate students, or students who are taking this course for graduate credit, must perform the following additional tasks. Enhance the Fork Join Pool Manager.java file to use Java method references and/or Lambda expressions wherever possible. Undergrads are welcome to implement these methods and features, but it's not required. Unit tests in the App Source Test folder are provided to increase our confidence that your implementation is working as expected. It's essential that you use the Android Studio GUI to run these unit tests locally in your computer, as described here. As usual, of course, testing only demonstrates the presence of bugs and not their absence, so don't rely solely on the unit test to detect problems in your code. However, please do run these tests prior to submitting your solution, and make sure you seek help if you have any questions at all about why any of the tests fail. Skeletal code for this assignment is available in my GitHub account. Now that you've set up your GitLab account, please pull this skeleton code into your repository, read it carefully, and complete the to-do markers. This part of the assignment is intended to deepen your knowledge of writing concurrent Java programs using the Java Comment Fork Join pool and its ManagedBlocker interface in conjunction with several popular Java barrier synchronizers. The solution enhances the Java Executor Service and Executor Completion Service frameworks covered in earlier assignments by eliminating the need for handling futures and ensuring that all beings start gazing at the same time. Now that we've walked through the specification for assignment 4A, let's take a look at the skeletons. We'll start off with the fork join pool manager.java file. So this file implements a being manager that uses the Java Common Fork Join pool to create a pool of Java threads that run being simulations. As you can see here, we're going to have another helper class called being blocker, and the being blocker class is going to implement the gazing logic of a being using Java's ManagedBlocker class, which of course is associated with Java Common Fork Join pool. So we'll look at this class in a second. First, let's come back here and take a look at fork join pool manager.java. So you'll have to define a couple of fields here. You'll have to define a CyclicBarrier field that can be used to ensure all threads in the thread pool start running at the same time. And there's also going to be a CountDownLatch exit barrier that ensures the waiting thread doesn't finish until all the beings finish gazing. So you have to fill in those. Then down here, we're going to go ahead and define a factor method called newBeing that returns a being blocker. All you have to do is remove the code that throws the unsupported operation exception with the factor method that does the right thing. That should be pretty obvious once you take a look at it. Then let's come down here and take a look at run simulation. So this is the entry point method that's called by the simulator framework to start the being gazing simulation. And you'll call a couple of methods here. First, you'll call a method that initializes the barrier synchronizers and assigns them to all the beings. And that, of course, is going to be the Initialize Barriers method. And then you'll call another method that uses the Common Fork Join pool to run a pool of threads that represent the beings in this simulation. And of course, that's going to be the processAllBeings method. So that should be pretty clear. Let's take a look at Initialize Barriers. This method initializes the barrier synchronizers and assigns them to the beings. So, of course, you'll start by initializing the entry barrier that ensures all the threads in the thread pool start running at the same time. And that should be pretty clear from reading the comments above. And then next, you'll initialize an exit barrier that ensures that the waiter thread, that's the main thread that is running the simulation, doesn't finish until all the beings finish their gazing. And then after that, we're going to call another method that will iterate through the beings and set their barriers accordingly. So that, of course, will actually be a method that's defined over here in the being blocker class called setBarriers. We'll come back and look at that in a second. So once you've initialized the entry barrier and the exit barrier, then you're going to call the setBarriers method on each of the beings, and you can iterate through that using the normal technique you'd use for this. Now let's take a look at a more interesting method. This is the processAllBeings method. This uses the Common Fork Join pool to run the beings in this simulation. And what this is going to do is it's going to call the getBeings method, which will then in turn return all the beings. And then you can iterate through that using a forEach method. And you'll iterate through each of the being blockers that's returned from getBeings. And you're going to execute each of these being blockers in the Common Fork Join pool. And inside the execute method, you're going to end up using the Fork Join pool's static ManagedBlock method in order to be able to go ahead and do the invocation on each of the being blockers. So that's what's going to then use the magic abilities of the ManagedBlocker mechanism in the Common Fork Join pool to be able to expand and then later contract the number of threads in the pool dynamically. Now, once you go ahead and start all those wheels in motion, then you're going to use the appropriate method that's defined on the entry barrier to indicate that it's time for all the beings to start doing their gazing. And of course, this is the magic of entry barriers and cyclic barriers that you're going to be learning about in other videos we'll talk about. And then after you kind of start everything in motion, then you're going to go ahead and wait until all the beings have finished their gazing. And that, of course, is going to use the exit barrier. And this will also give you some clues as to the appropriate counts you should have for the entry barrier and the exit barrier. The entry barrier should have the number of beings that are going to gaze +1 for this kind of waiter thread, if you will. And then the exit barrier count should be the number of being threads, because when those fall to 0, then we want this thread to finish and basically to wrap up all the processing. The shutdown now method is a no-op in this implementation. There's no need to have it at all, since the Java common fork join pool is a singleton that does not get shut down. So it doesn't have to do anything. So just leave that as a no-op for now. Let's go over now and take a look at the being blocker class. So as I mentioned before, this class implements the gazing logic of a being that uses the ManagedBlocker class that is in turn associated with the Java common fork join pool. You can see here that being blocker extends being and implements fork join pool ManagedBlocker. So it's going to get those methods that ManagedBlockers get. You're going to have to define a couple of fields here. One will be the CyclicBarrier entry barrier that will ensure that any given being starts when all the other ones start. And then we'll also have an exit barrier that's a CountDownLatch that ensures the waiter thread, that's the thread over here that's in the process all beings method, can be notified when all the beings have finished gazing. So that's the entry and exit barriers we'll talk about for barrier synchronizers. Take a look here. Here we have the set barriers method. This is what's going to be called over here in the fork join pool manager, right in this part of the code for initialize barriers. And you'll go ahead and call that and initialize all the fields. And then down here, we have the method you have to fill in. This is the main one. This is the block method. And this is going to run the loop that performs the being gazing logic, which I give you here with run gazing simulation. However, the main difference now is that you have to use the entry barrier to wait for all the beings to be ready to run, and you'll have to figure that out. It's pretty simple, but you have to understand it. And then down here, after you're done with the gazing, then you have to indicate that the being has finished gazing. And then you'll have to do the appropriate call there with the exit barrier to tell it that you're done. So you'll fill all that code out here, and you'll have all the various things that need to be done, and you can return the right value at the end here. Okay, is releasables just returns false, nothing fancy there. There's no real non-blocking behavior here. And then finally, you'll implement acquire Palantiri and gaze. If you haven't figured this method out by now, something is wrong because we've done it more or less the same way for all the other assignments. So just go ahead and take a look at the assignment 3A, and you should be able to reuse the code here pretty much out of the box. Now that we've walked through the specifications and the skeletons for assignment 4A, it's time to turn our attention to running the regression tests. As you can see, there's quite a large number of regression tests to run at this point. I think there's something like over 100 tests. These tests will evaluate your behavior and how well your program performs with respect to assignments 1A and 1B, assignment 2A and 2B, assignment 3A and 3B, and of course, finally, assignment 4A. Make sure that you copy over your code properly from the previous assignments, and then also make sure that when these tests run, that they all pass and work correctly. If you have any problems whatsoever, as always, please don't hesitate to come to office hours or post questions on Piazza. One of the things you'll notice is we have both unit tests and also integrated tests. The unit tests are typically tests that test with white box analysis using various forms of mocking, and then the integrated tests typically run the tests in some kind of stress test mode with lots of clients, lots of threads, and so on, just to make sure that there aren't problems that are having side effects that will cause your program to fail, even though they pass some of the unit tests. As you can see here, my master example, of course, passes all its tests. You can ignore this warning here about an illegal reflective access operation. That's just something that's internal to the mock-K mocking framework, so it doesn't matter. So that's the end of the walkthrough for assignment 4A. Please make sure you come and get help if you have any problems whatsoever.